Hello, my little mathematicians. Today we're going to cover the different inequalities, both how to write an equation and how to graph it. Let's go ahead and take a look. For number 1, it says it wants you to graph x is less than 2. And you can see that that kind of even looks like an L for less than. So at 2, draw a circle. And then if there's a line underneath, it should be shaded in, because it's including that point. If there's no line underneath, it's an open circle. And then it's less than, so where do numbers go less than 2? To the left. Or since the variable is on the left, you can kind of think of that as like your arrowhead. It's pointing to the left. See how they match? Okay. Number 2, I want to draw a circle at -7. Again, there's no line underneath, so it's an open circle. And it's the less than sign, so where do numbers get smaller? To the left. Notice how all the numbers here are less than -7. Number 3, it wants me to write this inequality from the statement. It says the sum, so plus sign, of x and 9 is less than. So that's an inequality sign of a less than 12. Now, before I can graph this, I need to solve it just like how I solve a normal equation. Think of this as like you're dividing an equal sign, because an inequality is kind of like an equal sign. It even has the word is there. How do you get x by itself? Do the inverse of adding 9, which is to subtract 9. Those cancel, and now you have x. Bring down your less than. 12 minus 9 is 3. So it ends with x is less than 3. So I'm going to draw a circle at 3. It's open because it's not including that point. And where do numbers go that are less than 3? These ones. So you can always check. It says x is less than. See how it's a little tiny dot end that's facing it? And the great big open end is facing the 3. So it's all in reference to the variable. That's what graphs are representing, is all the possible numbers. Well, all the possible numbers that are smaller than 3 would be 2, 1, 0, and so on. So if you ever see the word is less than, it's an open circle at whatever numbers here, and then an arrow pointing to the left. It also could be if you see the word fewer than, so is fewer than, it would be a less than symbol, or if you see the word below. So if it is below a certain value, then it would also be to the left. Okay, let's take a look at number 4. Number 4 says x is greater than 5. So draw a circle at 5. It's an open circle because it's not including the value of 5, right? It just wants the numbers greater than 5. Where do numbers get bigger than 5? Is 4 greater than 5? No. Is 6 greater than 5? Yes, and it's to the right. Notice how it almost looks like an arrowhead pointing in that direction. See how this matches my line? And you can use that little arrowhead trick when the variable's on the left. Okay, number 5. At 8, draw an open circle because it's not including that point, and it's the values greater than 8. So is 7 greater than 8? No. Is 9 greater than 8? Yes. So in that direction, these are all the values greater than 8. If I were to write this inequality from the statement, it says the product. Product means multiply. And I'm multiplying x and 4. Instead of writing x4, I'm going to write 4x, right? When you have two things touching each other, that means they're being multiplied. And we like our coefficients in front of our variables. So the product of 4 and x is greater than. So greater than symbol. Greater than what? 32. Now, before I can graph it, x needs to be by itself over here. So what's the inverse of multiplying by 4? To divide by 4. Those cancel. 4 divided by 4 is 1. So you have 1x, or just x. Bring down your inequality. 32 divided by 4 is 8. So now I'm going to draw a circle at 8. And it's not including 8, so it's an open circle. Where do numbers go that are greater than 8? Is that 7, 6, 5? No. Is it 9, 10? Yep. So that direction. So now I think we can establish that whenever you see a sign that looks like that, it's an open circle at whatever numbers here going to the right. And again, when your variable's on this side, you can kind of think of this as your arrowhead. It's pointing in that direction. my variable's on the left, look at that arrowhead is pointing in that direction, just like that arrow. Okay, the words that can indicate this inequality is if you see is greater than, is more than, or is above. So, it's above 0 degrees, or it's more than 0 degrees, then you would write that inequality. Our next one says graph x is less than or equal to -1. So is that including -1? Yeah, it even said when I read it aloud, or equal to. So when something was equal to a number, we shaded it in. It includes that point. So normally when it says x equals -1, that's what we did. But now it's that and the value is less than it. Is 0, 1, 2, are those less than -1? No. Is -2 less than -1? Yes, it is. Because I'd rather owe $1 than owe $2, right? And again, see how that kind of looks like an arrowhead pointing in that direction. Okay. Here at 4, I'm going to draw a closed circle because it's including that point because that line underneath says or equal to. And the value is less than it. Where numbers less than 4? To the left. For this one, and remember, you can always pause the video and try things yourself and then unpause it and come back and join us. Okay, and if you're back with us, you just tried this one. Let's see if you got it right. It said the difference, which means subtract, between x and 10 is less than or equal to 2. See how I wrote it as I read it? If not, go back and rewatch the video and then watch my hand move as I'm reading the question. Okay, now I want to go ahead and graph it, or before I can graph it, I need to solve it and get x by itself. So how do I get rid of this -10? Do the inverse of plus 10. Now I have 10 minus 10, which is 0. It cancels out. And you have x plus 0, or just x. Bring down your inequality and your 2. So do you see something wrong with this scenario? You should. Because what happened? I didn't add 10 to this side. We can do whatever we want as long as we do it to both sides. So I should have added a 10 on this side, right? What I do is when I add 10 on this side, I automatically do it here as well. So then I don't forget to do it to both sides, okay? Because otherwise you could fall for the trap that I just demonstrated, okay? But when you do 10 plus 2, you get 12, right? Not 2, but 12. But that makes a huge difference if I were to just jump straight to the graph from there, right? Okay. So again, when you do the inverse step, make sure you do it to both sides of your equation or inequality. Now I have x by itself, and I simplify the right side, and I got x is less than or equal to 12. So I find 12 on here. Is it an open or closed circle? It's a closed circle because it's including the point of 12 because it's less than or equal to. It's including that point. And I said or less than, so is 13, 14, 15 less than? No. Is 11 less than 12? Yes. So to the left. Now notice that the pattern with all of these, they were always at whatever number was here going in the left, and I shaded in the circle because it was including that number as well. Okay, and finally for our bottom ones, it says graph x is greater than or equal to -3. So at -3, I'm going to draw a closed circle because it's including that point. It's or equal to. And then the value is greater than. If you're kind of stumbling of how did she know it was greater than or how did she know it was less than, it's always focusing on your variable, right? Because this is representing this number plus all the other possibilities in either direction. So if it's the great big open end, see how it's like the great big alligator mouth, like it's big, it's facing the variable, that's a greater than sign. Versus this one right here, facing your variable is that little tiny dot end right here. And it almost looks like an L facing it, an L for less than. So where do numbers get smaller? To the left, okay? Or you can use that arrowhead trick if that helps you. All right, going back to this one, it says it's a greater than sign. So where do numbers get bigger? To the right, okay? Because Going this direction, you're heading towards positives, and that's bigger. Right here, you have 9, and it's a closed circle because it's including that point. It says or equal to, and it's a greater than sign facing my variable. So where do numbers get bigger? To the right, because 10, 11, 12, those are all bigger than 9. Okay. Try to write this again. If you want to pause the video and try it yourself first. Quotient means you're dividing. The quotient of what? X and 5 is greater than or equal to 3. Okay, so there's the inequality. And then to solve it, what's the inverse of dividing by 5? To multiply by 5. Whatever you do to one side, you do to the other. Now, if you were to think of this as like 5 over 1, see how these kind of cross cancel and you get 1. And so then you have 1 times x, which is x, over 1 times 1, which is just 1. So x over 1 is just x. I got x by itself. Bring down your inequality, and 3 times 5 is 15. So I'm going to draw a dot at 15. It's shaded in because it's including that point, and it's a greater than facing my variable. Numbers get bigger to the right. Okay, or again, the arrowhead trick, right? It's pointing in that direction. Okay, so you saw the pattern. When it looks like this, at whatever numbers here, I draw a circle. It's shaded in if it has a line underneath. It's left open if it doesn't have a line underneath because it's not including that point. And then if it's the great big open end facing your x, it goes to the right. Just like this one, the great big open end was facing your x, so it went to the right. The little tiny dot, see how there's like a little dot right there facing my variable? That's a less than, or it even looks like an L for less than, so it's going to the left. This one, the little tiny dot end is facing the x, so it's going to the left. Other words that mean is less than or equal to or is greater than or equal to, of course, we know is fewer than or equal to would be here, or is more than or equal to would go here. I'm not even going to waste your time to have you write it, but these ones are important. If ever you see the word at or no, it's the opposite way you think. So at most you think would be here, but it's actually there. That's a less than or equal to sign. Because think about it. If you were to have 16, you could be equal to 16 to drive, right? Can 15, 13, 12, 11, 10, 9, 8-year-olds, can they drive? No. Can you have 17, 18, 19-year-olds drive? Yes. And I just realized that this is a horrible example to use because we want to put at least 16 years old to drive, right? And that would be here. So 16, you want people older than 16 to drive, right? So it would be a greater than sign going in this direction because 17, 18, 19-year-olds can drive. 15, 14, 13, 12-year-olds, they can't drive. Only older people than 16 can drive. You have to be at least 16 years old to drive. So you see the word least and you're like, oh, it's a less than sign. No, it's actually a greater than sign because at indicates that it's the opposite direction of what you think. It's actually greater than, heading towards the right. At most, that would be an example of, think about like getting into Disneyland. In order to get into Disneyland for free, you have to be at most 2 years old. So 1-year-olds, babies, they get into Disneyland for free. But as soon as you get 3, 4, 5, 6, 7, you guys, you can't get into Disneyland for free, right? Only 2-year-olds and younger. So you have to be at most 2 years old in order to get into Disneyland for free. But you see the word most, you would actually think it's a greater than, but it's actually a less than. The other word that indicates the opposite way you think is no. So if I were to see no more than, automatically I would think to go here with the greater than, but it's actually less than. Again, you can be no more than 2 in order to get into Disneyland for free. And then for this one, if I were to say you can be no less than 16 years old in order to drive legally by yourself, you would think, oh, less than, so it's a less than. No, it's actually a greater than. So like 16, 17, 18, 19-year-olds, they can drive legally by themselves. So no less than 16 years old to drive by yourself. Whenever you see the word at or no, it's the opposite direction of what you think. And create little scenarios like this and like test numbers and see which makes sense if you're ever questioning yourself of the direction. Hopefully this helped clear up a little bit of confusion that you had regarding which direction to do graphs.